This is Mrs. O'Neill for AP Chemistry, Chapter 9, Section 4, Covalent Bonding and Orbital Overlap. The objectives for this section are to recognize the electrons are being shared between atoms, of course in a covalent bond, and this valence bond theory is going to help us visualize what is happening between those electrons that are being shared. What's that overlap? What does that mean visually? So again, I suggest pause, fill in the blanks, and then play to hear my words. Valence bond theory is really just the region between those atoms where those electrons are being shared. So the overlap of those orbitals, the overlap of the S-shape orbital, the overlap of the P-shape orbital, the overlap of an S and a P-shape orbital. What does that really look like in a covalent bond? So this is the region that we're interested in. So we have an H plus an H, two atoms coming together to make the hydrogen diatomic molecule. So we're really interested in this overlap of electrons, the one electron from the one hydrogen atom and the other electron from the other. That's the region that we're going to focus on. Same thing with hydrochloric acid. The H electron sharing with the chloride electron, right? That area in between, that's the area that we're looking at. So we're looking at from the hydrogen, the 1s, right? The electron that's in the 1s orbital. And we're also going to be interested in the electron that's in the 3p orbital. And what does that really look like? The 1s to the 3p, what does that look like? And this should kind of help you understand the hybridization, right? So when we're looking at HCl, right, and we're labeling the SPPs, the reason for labeling the SPPs is the understanding of that overlap between the hydrogen and the chlorine, or the hydrogen and the carbon and methane, things of that nature. So hopefully this gets you to understand those electrons could be in the s orbital, it could be in the p orbital, and where in that region is that the overlap is really occurring. Here we have beryllium with fluoride, so we have beryllium difluoride, or we have beryllium fluoride. It depends on the chemist. Some chemists believe that beryllium is named as a metal, and some name it more as a non-metal. Either way, we have beryllium here in the middle, and we have an overlap between the beryllium and the fluoride on the left, and we have an overlap between the beryllium and the fluoride on the right. So here we would have an SP, or a hybridization or overlap of the SP hybridization of these orbitals. So hopefully this just gives you a better understanding of when we're talking about hybridization and we're talking about orbital overlap, we're just talking about the region where those electrons are being shared between two atoms. Okay, see you in class.